all my lecture series of automata theory and compiler design. In today's video, we are going to see about one case study on deterministic finite automata. The problem statement is a theater owner permits only three categories of people, that is a father, mother, their kids for a show. The seating arrangement is restricted as follows. So, எப்படி இருக்கலாம் அப்படின்னா any number of children can sit together. Any child followed by her mother can sit as a group. This can be repeated any number of times. Okay. The child followed by her mother, followed by her father can also sit as a group. This can be repeated any number of times. The theater should not be an empty. So there is no empty seat is permitted. So derive the regular expression and design a deterministic finite automata for that accepts only the valid seating pattern. This is the pattern. Any number of children can sit, and children followed by her mother can sit any number of times, and the child followed by her mother and father can sit any number of times. So the solution is yes, we can construct an automata using a deterministic finite automata that accepts only the valid seating pattern. So before going into construction, first we know about what is the finite automata. So the finite automata is a 5 tuples. It contains a q, epsilon, sigma and transition q naught and f. So q is a finite set of state, and sigma is a number of alphabets, and transitions is one from one state to another state. Next is a q naught is a starting state, and f is a final state. This is the finite automata formal definition. The finite automata, it is a two types. One is a non-deterministic and deterministic finite automata. So the difference between that deterministic and non-deterministic is, the deterministic is we have it for example, for a single input symbol, the transition is go to the single state only. But in the non-deterministic finite automata, for a single input symbol, we can transmit to any number of states for a particular input. That is the main difference between the NFA and DFA, and also NFA should contains the epsilon, but DFA should not contain the epsilon transition. So this is the DFA and NFA tuples. Only difference in the times of transition only. The transition function la we have the difference. Okay, the graphical representation of DFA அப்படினா, it can be represented using the transition diagram or the state diagram. The transition diagram contains a number of states, and the transition is represented in terms of an circle. States are represented in terms of a circle, and transition is represented in terms of an arrow mark. So the solution for the above problem is that we have 4 states like Q0, Q1, Q2 and Q3. So the Q0 to Q1, for example, there is a pattern like child followed by number of childs, or child mother, it can be repeated number of times, and child mother and father. This is the pattern should be designed. First, any starting pattern, the starting input is a child. So from the Q0, when you read child means it reaches the state. That is a Q1. So you have a child means single side or multiple childs, but there is no empty space could not be read. Okay, so the Q0 to Q1 அப்படிங்கும்போது the child acceptance state, only child அப்படின்னா Q1க்கு end ஆயிரும். That is a final state. So in the suppose you have a 2 child means there is a self loop in the Q1. So it Q0 Q1 accept number of child. Suppose child followed by mother means child, when you read child, go to Q1. From the Q1, when you read mother, go to Q2. That is another final state for the second pattern, child and mother. So followed by any number of child and mother can be accepted. Next pattern is the child, mother and father. That is a Q0, Q1, Q2, Q3. When you read Q0, Q1, Q2, Q3 directly, we can accept the third pattern. that can also be any number of times. So from the q நாட்ல again child and mother இருக்கலாம். again எனக்கு சைல்டு ஆரம்பிச்சுட்டு மதர் அண்ட் சைல்டு அந்த பேட்டர்ன் வந்து எனக்கு ரிப்பீட் ஆகிட்டே இருக்கலாம். ஸோ திஸ் இஸ் த ஸ்டேட் டயக்ராம். ஸோ q நாட் டு q1 அப்படிங்கிறது எனி நம்பர் ஆஃப் சைல்டு டுகெதர் அக்செப்டட். அண்ட் q நாட் q1 q2 அப்படிங்கிறது சைல்டு வித் மதர் நம்பர் ஆஃப் டைம்ஸ் இஸ் அக்செப்டட். q நாட் q1 q2 q3 அப்படிங்கிறது சைல்டு மதர் ஃபாதர் பேட்டர்ன் இஸ் அக்செப்டட். I hope you will understand how the deterministic finite automata is designed for the given problem. Thank you.